Exercise 2.5 is trying to get you used to seeing the carbons and hydrogens in a new way of drawing molecules called bond line structures. In bond line structures, carbons are replaced by points on a line. And hydrogens are not drawn at all. They're still there, they're just implied. So what you would need to know is that carbon forms 4 bonds, and so any bonds that are not explicitly drawn go to hydrogen. And that happens until each carbon has 4 bonds. So to give you an idea of how this works, let's just draw the carbons in here. So the carbons are at each end. So carbon is there, a carbon is here, a carbon is here, carbon is here, 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 here. So each of those would be carbons. And if you want to draw in the hydrogens, you have to think about how many how many bonds are already explicitly drawn. So if you look at this carbon right here, it only has 1 bond explicitly drawn. Since carbon tends to form 4 bonds, if it doesn't have a formal charge, you would want to add 1, 2, 3 more bonds. And those bonds that aren't explicitly drawn go to hydrogens. Hydrogen, hydrogen, hydrogen. And so that carbon would have 3 hydrogens. This next carbon here has 1, 2, 3, 4 bonds drawn. And so it already has 4 bonds, so we don't have to draw any other bonds in. That's fine as it is. It doesn't have any hydrogens around it. If you look at this carbon over here, it only has 1 bond drawn. So to give it 4 bonds, since it doesn't have a formal charge, or it has a formal charge of 0, we'd have to add 3 more bonds. And those implied bonds will go to hydrogens. This next carbon down here has 1, 2, 3, 4 bonds drawn in. Since carbon forms only 4 bonds, that doesn't have any hydrogens on it. This next carbon here has 1, 2 bonds explicitly drawn in. Since carbon forms 4 bonds, we would have to add 2 more, and those implied bonds will go to hydrogen. This next carbon down here has only 1, 2 bonds drawn in. Since carbon forms 4 bonds, we'll have to add 2 more bonds to that. 1, 2, so it's a total of 1, 2, 3, 4. And those implied bonds go to hydrogens. Oops. The next carbon here only has 1, 2 bonds explicitly drawn to it. Since a carbon without a formal charge has 4 bonds, we need to add 2 more bonds there, and those implied bonds are to hydrogen. The next and last carbon over here, that carbon has 1, 2 bonds explicitly drawn in. To get a total of 4 bonds around that carbon, you need 2 more bonds, and those implied bonds go to hydrogen. So you can see that if you have these bond line structures, they sometimes look less complicated than the Lewis structures. So compare the structure we have underneath here to this new structure I'm going to draw. So these two structures are the same. They're equal each other. But this structure on the right looks a little bit more complicated and would take a much longer time to draw. And so this shorthand way is useful. It gives you a sense of the carbons and how they fit together into what sort of shape. and it's much faster to draw, and so those bond line structures are a useful skill to have, to be able to draw them. At the same time, the hydrogens on this molecule and the carbons on this molecule will be important to be able to see, so you'll want to train your mind to be able to see those carbons and hydrogens there. So let's do a couple more examples. Every end of a line, every chink or corner is a carbon. So this is a carbon here, carbon, 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 and carbon. Notice that this is not a carbon. That is a bond going to the nitrogen. So the carbons are only in places where you don't have another atom drawn in. Okay, so those are the carbons. Then we would just want to fill in the hydrogens. Now we know if a carbon doesn't have a formal charge, and none of the carbons here have formal charges drawn in, then it has to form 4 bonds. So starting on the left, this carbon only has 1 bond explicitly drawn in. That means that it has to have 3 other implied bonds in order to get 4 bonds total. And all of those implied bonds always go to hydrogen. If a bond doesn't go to hydrogen, it has to be drawn explicitly. For this next carbon, it has 2 bonds explicitly drawn in. But the carbon needs 4 bonds, and so it must have 2 more implied bonds to hydrogens. This next carbon here has 1, 2, 3, 4 bonds explicitly drawn in. Since carbon only forms 4 bonds, that carbon has 0 hydrogens around it. You don't have to draw anything there. The next carbon is over here, and that carbon has 2 bonds explicitly drawn around it. To get a total of 4, you have to draw 2 more, and those implied bonds always go to hydrogen. Finally, the last carbon on the right, that has only 1 bond explicitly drawn in, 1 bond to it. And so to get a total of 4, you would want to add 1, 2, 3 bonds. All of those implied bonds go to hydrogen. And so that gives you a total of 1, 2, 3, 4 total bonds around that carbon. Okay, so notice that anything that's not a carbon, any atom different from a carbon, has to be explicitly drawn in. So you wouldn't be able to just gloss those over. You'd write those exactly how you would write them in a Lewis structure. And any hydrogen that's bonded to those atoms also has to be drawn in. So again, compare these two structures, and I'll just draw in the bonds here. So here, the structure on the left and the structure on the right are the same molecule. But notice how much cleaner, how much simpler, how much easier it is to get a grasp of the entirety of this molecule on the left is compared to the molecule on the right. Okay, next structure. First step, let's draw in the carbons. The carbons are always at the end of the lines and at these little corners in the middle of the zigzags. So this is a carbon, 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 and carbon. Now none of these carbons has a formal charge because we don't see a plus or minus sign on the molecule. And if a carbon doesn't have a formal charge, then it must have 4 bonds. Now, this carbon at the top only has 1 bond drawn in. That means it must have 3 more implied bonds. And implied bonds always go to hydrogen. They never go to any other element. So that carbon has 3 hydrogens around it. This next carbon down has 2 bonds to it drawn in, but it needs 4 total. So it must have 2 more bonds, implied bonds, which always go to hydrogens. So that carbon has 2 hydrogens around it. The next carbon down has 2 bonds explicitly drawn in. There's 1, there's 2, but it needs a total of 4. So it needs 2 more implied bonds, and those implied bonds go to hydrogen. So that carbon has 2 hydrogens on it. The next carbon has 1, 2, 3 bonds explicitly drawn in. It needs a total of 4, so there must be 1 implied bond. The implied bonds always go to hydrogen. So that carbon has 1 hydrogen around it. At the bottom, that carbon has only 1 bond explicitly drawn to it. It needs a total of 4, so it must have 1, 2, 3 implied bonds to hydrogen around it. And the carbon at the left has only 1 bond explicitly drawn to it, but it needs a total of 4, so it must have 1, 2, 3 implied bonds to hydrogens around it. So that carbon is bonded to 3 hydrogens. And so just for the sake of comparison, notice, and here I'll just draw these bonds in, notice on the right we have, these 2 molecules are the same molecule. Oops. On the right we have the Lewis structure, and on the left we have the bond line structure. And this one tends to be simpler, faster to draw, and because you can grasp it more quickly, it's more meaningful. But you'll still want to be able to see all of the carbons and hydrogens in this type of drawing with your mind. One note, we're showing that carbon needs 4 bonds in all of these. Remember, the reason for that is because carbon is in group 4a. It's the first element in group 4a on the periodic table. That means it has 4 valence electrons, so 4 unpaired electrons, and that means it can form these 4 bonds. So that's why we're trying to get 4 bonds around all these carbons. Okay, next one. So first, let's draw in the carbons. Now the carbons are at the end of every line and at every corner in between. So these are all carbons. All right, let's start at the top. This carbon here only has 1 bond drawn to it. It needs a total of 4 because none of the carbons here have a formal charge. And if carbon does not have a formal charge, or if it has a formal charge of 0, then it needs 4 bonds. So all of these carbons will need 4 bonds because none of them have a formal charge. So this carbon at the top only has 1 bond drawn. That means it has 3 other implied bonds to hydrogens to give it a total of 4 bonds around it. Next carbon down, this carbon has 1, 2, 3, 4 bonds drawn to it. So it already has 4 bonds, so it must have no hydrogens on it. Carbon to the right of it has 1, 2, 3, 4 bonds around it. That means it must have 0 hydrogens bonded to it. The carbon here only has 1 bond drawn to it. That means it must have 2, 3, 4, 3 implied hydrogens bonded to it. Going around clockwise, this carbon here has 1, 2, 3, 4 bonds drawn explicitly. That means there are no implicit bonds to hydrogens around it. This carbon here only has 1 bond drawn to it explicitly. That means that it has 1, 2, 3 bonds implied, bonds to hydrogen around it. This carbon here has 1, 2, 3, 4 bonds drawn explicitly around it, so it doesn't need any bonds to hydrogen to make 4 bonds around it. It doesn't have any bonds to hydrogen. This carbon at the bottom has 1 bond drawn explicitly around it. That means it needs 3 implied bonds to hydrogen in order to get a total of 4 bonds around it. The carbon here has 1, 2, 3, 4 bonds around it, so there are no hydrogens bonded to that carbon. The carbon here has only 1 bond drawn around it, so it needs 3 more, all to implied hydrogens, in order to get a total of 4 bonds around it. The carbon here has 1, 2, 3, 4 bonds around it. So it will have 0 bonds to hydrogen, to implied hydrogens. The carbon here has only 1 bond drawn explicitly around it, so it needs 3 more, all to implied hydrogens, in order to have a total of 4 bonds around it. And so just to compare these two molecules, and I'll fill in the bonds in just 1 second, these two molecules are the same. This molecule on the left and that is the same as that molecule on the right. But you can see how the bond line structure is clearer, cleaner, simpler, easier to understand. Nonetheless, you'll want to be able to see all of this in this molecule with your mind. Okay. Now, the carbons are all of the bends, all of the chinks or corners in the zigzag. So this is a carbon, 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 carbon. Notice there's not a carbon here. That is a bond to the oxygen. Okay, so to figure out the hydrogens, we'll choose 1 carbon. Notice that there are 2 bonds drawn explicitly to that. None of the carbons of this molecule have a formal charge because we don't see a plus or a minus sign, so all of these carbons need 4 bonds total. If only 2 are drawn, there must be 2 more that aren't being drawn, and those bonds are always to implied hydrogens, so that carbon is bonded to 2 hydrogens. This next carbon has 2 bonds drawn explicitly to it. That means it needs 2 more implied bonds to hydrogens in order to have a total of 4. This bond at the bottom left has 2 bonds going to it, drawn. That means it needs 2 more to implied hydrogens to have a total of 4 bonds around it. This carbon here has only 2 bonds around it. It needs a total of 4, so you add 2 implied bonds to hydrogens to get a total of 4 bonds around it. This carbon has 3 bonds explicitly drawn around it. To get a total of 4, it just needs 1 more implied one. The implied bonds are always to hydrogen, so that carbon is bonded to 1 hydrogen. This next and last carbon has 1, 2, 3, and 4 bonds drawn around it, and so it does not need any hydrogens around it. Notice that the atoms other than carbon, so oxygen here, are always drawn in explicitly, and also notice that any hydrogens bonded to those other atoms, those atoms different from carbon, are also drawn in explicitly. And so we can take this molecule is the same as this other molecule down here. We'll just draw those bonds in. So those 2 molecules are the same thing. You'll want to look at this molecule and see that one. All right. The carbons are every corner in the line, any corners. So that's a carbon, 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 carbon. Our first carbon at the top here has 1, 2, 3, 4 bonds drawn explicitly around it, so it doesn't need any hydrogens. Note that none of the carbons here have a formal charge. We don't see any pluses or minuses, so all of these carbons need 4 bonds around them. This next carbon here has only 2 bonds drawn around it. That means it needs 2 more implied bonds to hydrogen to have a total of 4 bonds. Carbon here only has 2 bonds drawn explicitly around it. That means it needs 2 more bonds implied around it in order to have a total of 4. Carbon at the bottom has only 2 bonds drawn explicitly around it. To get a total of 4, it must have 2 more. Those are implied bonds, and those bonds are always to hydrogens. Those undrawn bonds are always to hydrogens. This carbon has 2 bonds drawn explicitly around it. To get a total of 4, it needs 2 more. those implied bonds are always to hydrogens. So that carbon has 2 hydrogens around it. And this carbon has 2 bonds drawn explicitly around it. To get a total of 4, it needs 2 more. Those are implied bonds, and those implied bonds are always to hydrogens, so that carbon has 2 hydrogens around it. So this molecule, one last thing to note is that any atom other than carbon or hydrogen is always drawn in explicitly. And if there were a hydrogen bonded to that different atom, it also would have to be drawn explicitly. And so this molecule on the left and this other molecule on the right, these are the same. These are the same molecule. You'd want to look at this and see that. All right, this next one. So we know the carbons are at every corner here. So 1, 2, 3, 4, 5, 6 carbons. This first carbon has 1, 2, 3, 4 bonds drawn explicitly around it. And so it doesn't need any implied bonds to hydrogens. It doesn't have any implied bonds to hydrogens. And notice that none of the carbons here have a formal charge, so all of these carbons are going to need 4 bonds around them. This second carbon has 1, 2, 3 bonds drawn explicitly around it. But it has to have 4. That means one other bond isn't being drawn. It's an implied bond, and those implied bonds are always to hydrogens. So that carbon has 1 hydrogen around it. This carbon here has 1, 2, 3 bonds drawn explicitly. That means it must have 1 implicit bond to hydrogen drawn around it. The carbon at the bottom has 1, 2 bonds drawn explicitly around it. To have a total of 4, it must have 2 implied bonds to hydrogens around it. This carbon here has 1, 2 bonds drawn around it. To get a total of 4, it would need 1, 2 more bonds that are implied, and those bonds that aren't drawn are always to hydrogens. So that carbon would be bonded to 2 hydrogens. This carbon here has 1, 2 bonds around it that are drawn explicitly. It actually has 4 bonds though, otherwise it would have a formal charge. The bonds that aren't being drawn are implied, and those implied bonds are always to hydrogen. So that carbon has 2 hydrogens around it. Notice that any bond other than carbon and hydrogen is always drawn just as in the Lewis structure, explicitly. And so this molecule on the left and this molecule on the right are the same. You would want to look at this and see that molecule on the right. Okay, with H, so the corner is a carbon, so 1, 2, 3, 4, 5, 6 carbons here. Starting with this top one, that carbon has 1, 2, 3, 4 bonds drawn explicitly, and so it doesn't need any hydrogens around it. Notice that none of these carbons have a formal charge. We don't see any pluses or minuses anywhere. So all of these carbons actually have 4 bonds, even if not all of them are drawn explicitly. This carbon here has 1, 2, 3 bonds drawn explicitly, but we know it must have 4, otherwise it would have a formal charge. That 4th bond is implied, and implied bonds are always to hydrogen. So that carbon has 1 hydrogen around it. This carbon here has 1, 2, 3 bonds drawn explicitly. That means to get a total of 4, it needs 1 implicit bond to hydrogen. The next carbon at the bottom has 1, 2, 3 bonds drawn explicitly around it. To get a total of 4, it needs just one more implicit bond to hydrogen. This carbon here has 1, 2, 3 bonds drawn explicitly, but we know it actually has 4. The 4th one is an implied bond that we can only see with our minds, and those implied bonds are always to hydrogen, so that carbon is bonded to just 1 hydrogen. This carbon at the top left That has 1, 2, 3 bonds drawn explicitly around it. We know that the carbon actually has 4 bonds, though, otherwise it would have a formal charge, and so that 4th bond is invisible. It's implied. We can only see it with our mind, and those implied bonds are always to hydrogens. So that carbon has 1 hydrogen around it. Notice that any atom other than carbon and hydrogen is always drawn explicitly, just like in the Lewis structure, and any hydrogen bonded to those atoms other than carbon, have to be drawn in explicitly. So this molecule on the left and this molecule on the right are the same thing. Oops. And so you would want to be able to look at this one and see the one on the right. All right, this one's kind of tricky. You're looking at it from the side. The key thing here is that this is not a bond. That's not a bond. And so, or that's not a place where, that's not a carbon, I should say. So the carbons are at all of the bends, or the chinks here, the corners. So this is a carbon, this is a carbon, this is a carbon, 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 and carbon. Those are all of the carbons in the molecule. This here is actually a bond, it's just behind this bond here. So it doesn't stop, it's not like there's a carbon there and there. That is not the case. You're looking at the molecule from the side, and the only reason there's a break here is because this red bond is behind this green bond. So they're trying to show how the green bond blocks your view of the red one. Okay, so we know there are no formal charges in this molecule, and so all of these carbons must have 4 bonds, even if they're not all drawn explicitly. In order to figure out how many implicit bonds, which are always to hydrogen, are there, we'll pick a carbon, see how many bonds are drawn explicitly, here 1, 2, and then add hydrogens until we get 4 total. So if there are 2 bonds drawn already, we only have to draw 2 more hydrogens to get a total of 4 bonds. So that carbon is bonded to 2 hydrogens. This next carbon here has 1, 2, 3 bonds drawn explicitly, but we know it must have 4 bonds because it doesn't have a formal charge. The 4th bond is invisible, it's implied, and those implied bonds are always to hydrogens. So that carbon is bonded to 1 hydrogen. The next carbon here has 1, 2 bonds drawn explicitly around it. Oops. We know that it has 4 though. That means that the other 2 are implicit, and those are to hydrogens. So that carbon is bonded to 2 hydrogens. This next carbon here has 1, 2 bonds drawn explicitly. That means it must have 2 implicit bonds to hydrogens to have a total of 4 bonds. This carbon in the front there has 1, 2, 3 bonds drawn explicitly. But we know it has a total of 4 bonds, and so there must be 1 implicit bond to a hydrogen there. This carbon has 1, 2 bonds drawn explicitly. That means it must have 2 implicit bonds to hydrogens to have a total of 4 bonds. And last but not least, this carbon here has 1, 2 bonds drawn explicitly, and so it must have 3, 4, 2 more implied bonds to hydrogens to have a total of 4 bonds. Okay, so what you would want to be able to do is look at this molecule on the left and see that molecule on the right. So those are the same thing. All right, J. So remember, at the end of every line, in the corner in every line is a carbon. So this is a carbon, this is a carbon, this is a carbon, this is a carbon. Now, if you remember, when you have a triple bond, these carbons here have 4 bonds. They don't have any lone pairs. If you were to think about the shape, the three-dimensional shape, say, of this carbon, you'd say, okay, well, it's bonded to 2 atoms and has 0 lone pairs. That pattern, 2 atoms and 0 lone pairs, that, if you recall, was linear. That gave a linear shape. And so when you draw atoms like that, atoms with triple bonds, those carbons in the triple bonds are always drawn as linear. That's the three-dimensional shape that we learned about them in chapter 1. And so that's why this is drawn a little strangely here. So even though there isn't a corner in this area, there are 2 carbons at the ends of the triple bond, but they're drawn in a straight line because they're linear. Okay. So we'll go through these. Now, we don't see any formal charges here. That means each of these carbons actually has 4 bonds, even if they're not all drawn. And so let's draw them in. Any bonds that are not drawn are always to hydrogens. So this carbon on the right there only has 1 bond drawn explicitly. That means it must have 3 implied bonds to hydrogens to give it a total of 4 bonds. The next carbon has 2 bonds drawn explicitly. That means it must have 2 bonds implied to hydrogen to give it a total of 4 bonds. This carbon in the triple bond has 1, 2, 3, 4 bonds drawn around it. That means it doesn't need any more bonds, so it doesn't have any bonds to hydrogens. No hydrogens are bonded to that carbon. Same with that carbon there. The other carbon in the triple bond has 1, 2, 3, 4 bonds drawn to it, and so it doesn't need any more bonds. It wouldn't have any hydrogens bonded to it. Carbon right there has 2 bonds drawn explicitly. To get a total of 4, it would need 2 more. Those implied bonds are always to hydrogen. So that carbon is bonded to 2 hydrogens. And this carbon on the end only has 1 bond drawn explicitly. To get a total of 4, it would need 3 more bonds. Those implied bonds are always to hydrogen. So that carbon would be bonded to 3 hydrogens. And so this molecule here on the top and the molecule on the bottom are really the same thing. So when you look at this molecule on top, you'd want to see that molecule on the bottom.